Okay, hello everybody, and welcome to the penultimate session for today. We're kind of between you, the next session, and beer 30, so we'll try to stay on time. Apologies for the technical snafu. I always get confused by Macs until I'm an old-time PC guy. You'll be hearing from myself. I'm David Segleau, and I'm the Director of Product Management at Couchbase, as well as from my colleague, Till Westmann. And we're going to be talking about Couchbase Analytics, kind of a sneak preview. Analytics was announced as part of our 5.0 release, and it is in developer preview. And what we're going to talk about is, we're going to talk about the vision, why we created it. I mean, really, what were we thinking, right? We're going to talk a little bit about the queries in the product to talk about how you can issue analytical queries and how those work. And Till's going to talk more in detail about kind of the internals of Couchbase Analytics and how that works, and what is actually in the developer preview. So what's the contents of the developer preview and how can you download it? And then we'll open it up for Q&A. So I don't think the question of why analytics is kind of relevant in a very high sense, because why analytics got resolved, got discussed over 20 years ago in the 90s. Everybody understands analytics provides additional insight and value that's embedded in the data and allows you to extract that. But the question, I think, is why analytics in the context of an engagement database? Because that's what we've been talking about today. Why is analytics important, not generally, but specifically within the context of an analytics database, an engagement database? And the reason is customers want more insightful data. They want smarter applications. They want to know things, for example, they want to know things about what's hot, what's the trending data, what are the books being read, what are the movies being seen, what are the latest, hottest tweets, what's the latest thing that the president has tweeted. So what's going on I want to see that in my application. I want to experience that. I want to have an experience of what's happening now. And analytics can provide that information to the application. I want to know as a user kind of what's next. If I just bought a book on Amazon.com and I get a bunch of recommendations about other books that I might be interested in, that's interesting to me, that's useful. And in fact, I do that all the time. I might buy an object or I might purchase something, but I want to find out what the company or what the provider suggests I do next. And you can think about that not just in terms of sales, but you can also think about it in terms of field service, for example. I just repaired the third bolt from the left on this machine that's on the manufacturing floor. Wouldn't it be great if the application said, oh, 9 times out of 10, you also have to adjust the other 3 bolts, right? Wouldn't it be great if the database, if the application could tell you what the next probable thing is you're going to have to fix, rather than coming out 2 days to fix it because it vibrates because you only changed or tightened one of the screws? And then I'm also interested in hearing about if there's a scarcity or if there's an availability issue. For example, there's only 5 left or 10 minutes left to this sale. I want to know about that because as a user of that application, it kind of gives me a sense of urgency, right? I'm not going to walk away from the screen. I'm going to make a decision. And in fact, if I know how many things are left in inventory, I might buy 2 of them or I might buy 3 of them. But basically what it lets me do is make more informed decisions. I get a smarter, better experience because analytics are being surfaced through that engagement database in the application that I'm using. And then if we look at corporations, if we look at companies, what they really want to find is insight about their operational data, right? They want to get insight about this data that they probably haven't been collecting a whole lot of, and they're starting to do that as part of the engagement database. I want to know what the patterns are within that data. I want to know what the hottest web page is, and I want to know what buying patterns exist, but I want to find the things I don't know. A lot of times people look at analytics and think, oh, I'm going to run these analytical queries to tell me things about my data. But typically they think about them in terms of tell me things I kind of already know. Tell me the web pages that are most often hit. Tell me the products that are most often sold. Well, I want to look for patterns that I don't know about, and that's what analytics lets us do. And that all involves forming correlations between events or forming correlations between data and cohorts. if you think about how businesses group problems, group customers, group products together, it's all about correlation and cohort analysis. So letting me do that inside my operational data lets me find groups of events, groups of purchasers, groups of products, groups of web pages that typically work together, and gives me better insight not only about how to manage but how to drive my business. And then finally, we often think of analytics as dashboards that tell us what just happened. Well, next to that dashboard that told me what happened, I'd love to have a dashboard that says this is probably what's going to happen next. So the thing that I want out of analytics as a business is to be able to tell me what the next probable thing is and show that to me as well so I can react to it possibly even before it occurs. So why did we build Couchbase Analytics? What were we trying to solve when we were looking at this problem? Given that engagement databases need analytics in order to satisfy customer demand and in order to provide better insights to businesses about their operational data, the first thing we said was, well, you know, it's kind of a pain to not be able to have OLTP and OLAP in the same database. You really want to have those two things in the same platform. And I really don't want to export data to some separate OLTP system because there's a bunch of penalties I pay every time I do that, right? I have to go through the overhead of ETL. And ETL, quite frankly, is in many cases evil, right? It's got extra administrative costs, it's got extra programming costs, it's got a huge latency built into it, and oh, by the way, I have to manage this separate cluster with these separate characteristics over here on the side. And I really don't want to do that. What I want to do is get the ability to query, to use analytics on my operational data inside my cluster. So it reduces latency, it reduces complexity, I don't have to have another system to manage, and it enables more intelligent applications. My first goal, make customers happier with the experience they're having. And then finally, it gives me the opportunity to explore my data, to find relationships and patterns that I didn't know were there. So Couchbase Analytics is that ability to do OLAP and OLTP in the same data platform. It enables the Ask Me Anything. So part of what Couchbase Analytics does is it enables businesses not to just ask the go get me this question, go get me this record, go get me this document. It says, let me explore my data. Let me find out things about my data. So let me do ad hoc queries. It allows me to do workload isolation, so I can put analytics over here on the side, and I don't have to impact my OLTP applications. So all my OLTP applications that are using nickel and using key value operations are not affected by what I'm doing over here in analytics. But I've got the data over here that I need in order to issue those queries. I can scale analytics based on my needs, my analytical needs. If my analytical needs are small, they can be a few nodes. It can take as long as it takes. If my analytical needs are for real time, I might create extra nodes. I might create extra capacity on the analytics side so that I can process those analytical queries faster. But the important thing is I don't want to learn a new programming language, right? Analytics in a data platform that's built around customer engagement and agility and flexibility shouldn't be about me putting on my thinking cap and having to learn a whole new language or a new paradigm for accessing my data. So I want a common programming API, I want a common language API between the two. And I want unified management. One of the things we talked about is ETL is bad because I got to put the data over here and I got to manage it over here. I want it all under one management and all in one platform. And I want that synchronization, don't want that lag that I have with ETL. I want that synchronization to be as fast as possible. And in Couchbase, you have it essentially at the speed of memory. So we're moving data into the analytics nodes using DCP, using the common infrastructure that we already have for other services within Couchbase, and you're getting essentially immediate results on your analytical platform that you can then run queries on. So let's talk a little bit about the programming language that you're going to use, the language you're going to use on the analytics platform, And for how many people here have never heard of nickel? I hope nobody. And how many people here are not familiar with JSON? Okay, everybody is. So here's two JSON documents. One is, and this is a part of our beer sample. Hopefully everybody's seen our beer sample as well. One is a beer type document, and the other is a brewery. And this is kind of in our standard examples repository. And what we're going to do is kind of show you're using the same language that you would use pretty much in NCL or in SQL to do queries. Here's a standard query where we're looking for 3 beers and their breweries. We have a limit, and we have an order by, and we have a join on a primary key. Nothing surprising there. It's pretty much vanilla NCL or vanilla SQL. Everybody knows how to do that. But in this next query, we've kind of added a wrinkle. We want to find the beers that are used more than once by different breweries. So we're no longer joining on the primary key. We're now joining on the name. This is a self-join between the beer object, the beer table, and the beer documents and the beer documents themselves. This is something you can't do today in NCL because the name column is not indexed. And for very good reason. I mean, you don't want to run essentially multiple table scans in NCL and affect OLTP. But you might want to do that in analytics because it's a separate service with its own resources. So in the analytics service, you can go ahead and issue these kinds of queries over columns whether they're indexed or not. So the analytics service is organized so that table scans, when required, are parallelized across multiple server nodes. Until we'll talk more about that. In our third example, we're showing an example of using an outer join, which essentially shows that you can nest a query inside a query. And not only can you do it at the level of the language, but you can do it, we return the results also as a JSON document with embedded objects inside it. So it's a fully composable language. You can express nested relationships in the query, and those nested relationships are represented in the output as well. One of the things you'll find with a lot of BI tools is they grew up in the Excel world and the relational world, and often what they'll do in the result set is they'll flatten it, and you'll get a flattened result set. In the case of analytics, you won't. You'll actually get JSON documents with embedded objects inside them. And then finally, kind of the bread and butter query for most people running analytics. It's a simple count with a group by and a having clause. This is kind of what people do every day. Give me a count of this many things based on this qualification, group it by this and order it by that. This is kind of what you'd expect probably in Simple Analytics 101 or Aggregation 101. This is what you do in SQL. It's the same thing you do using the analytics service. So how do you get started with analytics? How does this work? So once you've created your analytics nodes, the first thing you're going to do is you're going to create a bucket to contain the data that you're going to be moving, or you're going to be copying over from the OLTP side of the platform to the analytics side. And the second thing you're going to do is create a couple of data sets to hold that data. And a data set is simply a way of grouping documents of like type together to make them easier to query. So in this case, we're creating a bucket to contain all the documents that are coming over, and we're creating 2 data sets, one called beers and one called breweries. And you'll notice that they're filtering on type. So the beers will have all the documents of type beer, and breweries will have all the documents of type brewery. And then once we've established that relationship, we say, okay, start up DCP. Start moving mutations over as fast as you can into the analytics database. And if I leave this on and it moves all the data over and mutations happen on the JSON data inside the OLTP engine, those mutations get put on the DCP queue and get moved over in a memory-to-memory transfer over to analytics. Once the data's over there, I can go ahead and do any kind of select that I want. And then if I want to unwind the things I've created, I can disconnect, and I can disconnect anytime. There's actually applications where people might want to be connected and get mutations during the day and then stop getting mutations at some point. So they can always disconnect the DCP stream, do a bunch of queries, do a bunch of activity in the analytics, on the analytics side, and then start it back up again. So connect will essentially start up that DCP stream, disconnect will stop it. And then of course we can drop data sets and drop buckets as well. Any questions on that portion, kind of the intro to kind of analytics? Yes?
When you set up that stream to begin the DCP capture for the analytics service, how do you know that it's fully replicated before you perform the query?
So the question is, once we set up the DCP stream, how do we know that it's actually replicating before we run the query?
Yeah, when it's ready, yeah.
So it will start, it'll immediately start moving data over. And is there a status that's available?
Well, there's not. And the point is, it's kind of tricky to say, right? I mean, because, I mean, if your load is high, right, what is kind of the status you want to know? I mean, there will be at some point the way to have something like request plus, where basically you know up to the point, right, which doesn't guarantee you to be current. It's just guarantees you up to the point that you get
So there's some sort of lag or progress percent replicated something. Yeah.
Yes.
Any other questions?
Oh, I don't have a microphone. Nobody heard what I said.
Okay, go ahead.
Good. Okay. So, yeah, so I'll repeat that just, so the question was about, how do you know that you have kept up with you started your DCP connection, data comes flowing to you, and you know, okay, when am I up to speed what was already in the data? And the thing is that right now in the current DP, there's no way to do that, but basically the next thing that we'll do is make sure that there's a way that you can at least go to the point where you ran the request. Okay, all right. I think it's my turn right now. Some more internal things. And the first thing I would like to talk about is about, am I on the right slide? Interesting, that's different here. So the first question you ask, of course, okay, so you already had the wonderful nickel query, you can run queries, and now you tell me, oh, I got another query. And you ask me, okay, why do I have two services? And I tell you, okay, it should have the same interface. So probably you tell me, okay, if it has the same interface, so why is there a difference? And the difference is, as in the olden ways, right? I mean, there is a difference in the operational characteristics of the workloads that you're running. So you have very different workloads, you have very different use cases. And to do that, you also need a different architecture for the execution engines that do that. And because, I mean, the one use case you have is on the left side, right? I mean, that's kind of how we summarize it. You have the query service, which will allow you to run many small queries, right? And each of those queries touches a very small amount of data. And on the right side, we see the analytics service, and the analytics service has fewer queries, but each of them touches a lot of data, maybe all of the data that you have in your system. And so we have now, wait a second, sorry. And so I'm claiming that to do these two different things, right, you need different architectures. And I think we have seen that also in the relational database world. And just to prove the point, or not to prove the point, but to illustrate the point, we've done a small experiment here. And so we took this query. That's a very simple query. Again, it's that get the 10 chattiest users in a time frame on some social network. And okay, you get your user, you get the count of the messages that they got. It basically takes as an input, it joins the messages and the users on the author ID or the user ID. And then it has a window. Basically, it filters this into a window, is a time frame between two timestamps. Right? So when the message was sent, that's between two timestamps. And I can use this filter to limit the window, to resize the window, and to see kind of what's happening in the different services when I run that query for different windows. And so we ran this, and that's kind of what the graphs look like. So if you see from left to the right, the leftmost column is, or pair of columns is 1 minute, where the time frame is 1 minute, which is less than 10 objects that you're getting. The second one is you're running for an hour, which is less than 500 objects that you're running. The next one is 1 day, which is less than 5,000 objects. Then you have less than 1 week, which is less than 25,000 objects. 1 month, which is less than 100,000 objects. 3 months, which is less than 300,000 objects. On the right, we have 6 months, which is less than 600,000 objects. Okay. And as you see on the left side, so in the initial case, so you see the red bar, which is the query service, which is much lower than the analytics service, and that is because that's how the NoSQL service was designed. So the query service was designed to be optimized for small requests, for small amounts of data. It will basically do a quick compilation where the compilation speed is important. It will run the request on a single node. It will run it in parallel on a single node, but it will run it on a single node and get a few records and return them quickly. What will happen on the right side, on the left side for the analytics service, it runs a parallel query. So what it does, it gets the query, it does some nice optimization for some more complex queries, then it creates a parallel job, it distributes the job to the cluster, then it starts the job, and by the time it has started the job, right, the query service has run a few circles around it and it's done already, and you have done whatever. However, if you look on the right side, the situation is quite different. Right here you can see that the analytics service is quite a bit faster than the query service, and that's because now basically all the investment that we took in parallelizing the job, in distributing the job, in running the job on the whole cluster has paid off, and you get significantly better performance on that side. So that's kind of a suggestion on why this actually makes sense to have two different services. All right. So, okay, so what does this look like? So let's go back to what we wanted. So basically we claimed what we want to have are separate services on separate nodes. And if you look at this illustration here with this architecture kind of illustration, so really we separate the nodes. We have the data nodes, we have the analytics nodes. The data nodes service the small little requests, and the analytics nodes kind of service the big requests that we have on the right side. We get the workload isolation really by running on different systems. On the left side, the data nodes will be those are the key value stores, and on the right side, the analytics nodes will be the nodes that store the analytics data that you're running the analytics on, and that also will run the requests. And the request processing will be distributed on all nodes, or a limit or a subset of those, if you specify so, of the right side of the analytics nodes. So the processing is completely in parallel. So you have all of the usual kind of relational operations that you have, that you can parallelize, that you have also in database systems. Everything is parallel and nicely memory bound, so you don't fall over. So you basically have everything that you expect from a database system, from a parallel database system is available here. And also the shadowing or the replication of the data sets via DCP also works fully in parallel. So it's every node on the left talks to every node on the right, kind of minimizing the number of connections that you need to get the data over there as fast as possible at memory-to-memory speeds, as David mentioned. All right. So now we've explained to you, first of all, why we want it, then we explained to you how to use it. And now we've recently released a developer preview, DP2 of analytics. And now we'll tell you also what's in there, and so that you can use it. So first of all, let me tell you where we are with respect to our aspirations. So our aspirations were that, okay, so we want to be able to run ad hoc queries that can do anything. And right now in the current developer preview, that's true. So we have the query language. You have seen the query language. All of those things work. That works in parallel. So we give ourselves a green check mark on that. Then we also have the workload isolation. I mean, as we talked before multiple times, they're separate services. We can scale them separately. That's fine. It has the other check mark there, the scales independently. That is a true statement because actually it does scale independently. However, in the current DP, the scaling is relatively crude, which means that if you want to change the size of a cluster, you have to stop it, change the size, and restart it, which is kind of crude and certainly not at Couchbase levels of quality of service, right? If you have a Couchbase cluster, you expect to click the button, add a node, click on rebalance, and life is good again. And that is not the case in the DP. And so that's why it only gets the yellow check mark. We are talking about the common programming model and the common data model. So the HTTP interfaces, so the programming model is the same. The data model obviously is also the same. However, The query language, as we just talked, still has some differences, so we're not 100% okay there, but that's what we're working on. And so that will also happen. So that's why it also gets a yellow check mark. The unified management kind of goes along with what I just said about the independent scaling. So it doesn't work like Couchbase yet. It's not integrated into the Couchbase server so far. So the administration is actually very simplistic at this point in time. So that is work in progress. That will be part of the next developer preview, where we'll have the integrated version that provides the Couchbase typical management. And yeah, the fast data synchronization, I think that gets a green check mark. The DCP connections work and behave nicely as a good DCP client should. So what's in the DP? So in the DP, what you'll get is something that is a standalone service. So it's not part of the Couchbase cluster, as I just said. It provides you a few HTTP APIs to run SQL++ queries, to do your data shadowing or replication. And it provides very, very manual administration options. But it does provide an equivalent to the query workbench, which we call the analytics workbench. So you can connect to it with your browser. If you have used the query workbench, that will all be very familiar, and you can run your queries the same way. Since DP2, it also now has SDK support. So Couchbase SDKs for Java, PHP, whatever the list is, supports the concept of an analytics query now, and so you'll be able to run those with the SDKs. And so we have this incredibly complicated installer for this, which is a zip file. So you unzip the zip file, and inside of the zip file you will find a very simple shell script that will allow you to run a mini cluster on one node. So if you just want to get started and playing, you unzip, you start the shell script, and you have a cluster up and running, and you can connect to the workbench and do whatever you want with it. We also have a few other scripts in there, which are Ansible scripts that allow you to build a bigger cluster either on your own machine or on EC2. If you want to do EC2, basically you provide your credentials in a configuration file and a YAML file, you start it, and you run the cluster of the size that you want on EC2. So now if you were to actually run this mini cluster on your machine, and you wanted to try this out, and you would say, oh, what is this thing actually doing? So then you will find 5 processes so far, and that's what you see on the right. So we have one process that is called CC driver, 2 that are called NC service, and 2 that are called NC driver. And the CC driver, that process will contain what we call the cluster controller. It contains the HTTP APIs, it contains the workbench, and it contains the SQL++ compiler and the metadata manager, which is required to compile the queries. It will create the job and manage the cluster and deploy the job on the cluster. Right now, in the current DP, that is a singleton. So in terms of high availability and failover, if you kill that, life is over. Then the next 2 services that we see are the NC services, which are just simple babysitter processes which start and stop the NC drivers. And the NC drivers are the actual processes that do the work. They contain the parallel data flow engine, they contain the storage, and basically they actually run the job. And so we have this simplistic cluster on a single machine that you can take a look at and play with. But if you have a real deployment, then basically all of those things would be on separate machines that run independently. All right. And now, basically, that you know why you need it, and you know how to use it, and you know what you will get with a DP, you can just go there and download it. It's very easy to find. You go to Downloads, then you click on the Extensions tab, just in case you don't find that immediately, and then you get the current the preview. Yeah, it's available here. It's available now. It works with the Couchbase 5.0 beta. So if you want to run this against your wonderful beta that you've downloaded today, then that works as well. I'm done. Questions?
What kind of impact do you think this is going to have on your deployed Couchbase environment? Let's say you have a 6-node cluster and you want to add analytics to it. Maybe a couple of nodes. I realize this is a very open-ended question. You can answer it by the typical tech answer, it depends. But what is your anticipation?
Yeah, okay, so I'll repeat the question first. So the question is, so if you have a Couchbase cluster of size, for example, 6, right? You have 6 nodes and you want to run analytics on that. What do you expect to need? And of course, you're completely right what my answer will be. It really does depend. I think, I mean, in principle, you should be able, I mean, if you have very high update workload, right? I mean, you have kind of 2 problems, right? The one problem is that you need to keep up with the ingestion speed, right? And the other problem is that then you need to run queries on that. And of course, you have several options there, right? I mean, if you're really at the maximum of the ingestion speed, right, you might even need more analytics nodes than data nodes to keep up with that, right?
Which is typical of analytic systems. They're often bigger than the databases and that's
Exactly, right? But if you basically, right, if you get started, I think it's kind of hard not to give the "it depends" answer, right? You realize that, so and I'm giving it. Yeah, I think it should be, right. I mean, the goal is to be in the 1-to-1 range.
The other part of that is the persistent data that this is in this environment. Is that being replicated to the analytic system, or is the persistent data on the OLAP side maintained and the analytic side temporary? In other words,
Yeah, so that's a very good question. So the question is, so where is the data persisted and kind of where is the truth, I think. And so right now, in what we're doing right now, the truth is on the data side. So basically what we're doing is for analytics, we're creating a single replica of the data. And so because we don't replicate it again, right, basically if you lose that, it's gone.
right, you can just build it again.
Yeah, exactly. Then you can just re-ingest it and get it again. However, of course, there are use cases which should suggest that the analytics data might actually be bigger, and that is certainly a thought.
In theory, the legacy data of the system will grow.
Exactly.
And be supported by analytics would definitely be bigger, so that with the analysis and use of that information always is more important.
Yes. So I'll just try to repeat. So basically, your point is, so usually analytical data gets bigger over time because one of the reasons is because you keep historical data around, right? And if you saw what we just showed in terms of the DDL, the first use case that we're addressing is you don't keep historical data around. Basically, you have the data that you have on the front end, right? And you send it to the back, and you run your analysis there in a workload isolated way. But certainly, the use case of historical data is a very important one. Yes, please.
Can you describe a little bit more architecturally as how you do your OLAP thing? He basically described the overall architecture, but underneath you didn't really how much is really.
Well, I mean, it's basically, so to some extent it's what people usually do when they build parallel databases, right? I mean, basically you have partitioned parallel implementations of the relational operators that execute the plan. So the scans are parallel, the joins are parallel, the sorting is parallel. So all of these operators that you usually have in a plan for a database, right, are executed in parallel with memory boundaries in mind. So, which means that when you could have an intermediate result that's too big, right? That's too big to keep in memory, right? Because you do a join, you do a cross product, right? And very quickly your data gets really, really big. In that case, the system would also swap out the data to disk and get it back in, which would of course not give you the greatest performance, but it would also not fall over and still gracefully degrade into a worse state. Yes?
The only thing back is something like on the RDMS, you use columnar database to do this analytics. So is it something similar that you do behind the scene?
Yes, it's basically, it's the full thing, yes.
Columnar kind of thing?
No, it's not columnar. It's not columnar. It's just parallel, right? It's still doing our objects. It's our JSON objects, right? We keep the JSON objects as they are, but it parallelizes the whole processing. So when you do an aggregation, right, you do what other people also do. You first aggregate locally, and then you take those intermediate aggregates and you aggregate them completely. If you do joins, you partition the data and you join the partitions and then return that. So it's all partitioned in parallel. In the current DP, you cannot. In the future, you will. Oh, I didn't repeat the question. The question was, okay, can you...
was the index of the analytics node.
Yeah, no, but first, I want to repeat your question. Your question was, do you have indexes on analytics? And the answer was, not in DP2, but soon. Okay, and now?
Next question, I just learned about the index replica. That's going to be available as well. When you have indexes on DB3, and index replica will be available again.
No, the indexing works differently on the analytics side. So on the GSI, the global secondary index that we have on the indexing service, you have, as it says, it has this global index, right? You have one index that you take a hop to or to the replicas and then go to the data. On the analytics side, the indexes will be co-located with the data. They will be local, yes, exactly. So the question was, what is the performance benchmark against the traditional tools? So we did one 2 years ago, I think, and we compared against, some of the, unfair comparisons. We compared against Hive. That's not very hard. And we also compared against commercial parallel database systems, and we were in a similar performance range as a commercial parallel database system.
I would like to know if you're going to find any way of connecting to conventional, let's say, ES tools, how to use any existing tool.
So the question is, so what do we do about connecting to traditional BI tools? And so I think I have a twofold point here. One of them is we don't need to, because our friends from Slam Data over there, they do great analytics on JSON data, as they just told us. And the other answer is we're thinking about that.
My first question is, will this be a standalone service or application, or will we eventually be embedded as part of one more service that Couchbase provides?
So the question is, will this be standalone or integrated into the Couchbase cluster? And it will be integrated into the Couchbase cluster in DP3. That's the current work.
Can it run as a standalone cluster, so we don't impact the current cluster?
The next question is, can it run as a standalone cluster? I think the way that to think about it is that you have a Couchbase multidimensional scaling, right? So basically you can allocate certain services to certain machines, and in that respect you can separate them and you run them on a separate machine, right? So. Yeah. More questions? Okay, one more. Okay.
Is it equal to run your own clustering algorithm on the data?
Sorry, can you repeat?
Is it equal to run your own algorithm on the data using the analytics? Like, let's say I have my own clustering algorithm and I have the data.
So right now the interface that you're getting to it is SQL++, and so I think to some extent that means the answer is no. I think there is, I don't know. There are different options to do that, right? And I think we're looking into options, but I think we haven't said yet if that's something we want to basically attack on our own or if we want to integrate in that area.
So in the future plan, is R is going to be part of
So the question is there R in the future? And it's very hard to say no, but I would say it's not very close.
Not in the near future.
Yes.
other products probably.
Yes. Okay.
Are there any plans to support aggregations over the results of queries against inverted indices, like in the search service and whatever you guys mentioned?
So okay, so by the time, so the question is, are there plans to run aggregations over the result of inverted indices from FTS? And so by the time that I'm thinking about it, you realize that there are no active plans right now, but
Good suggestion.
it's a good question. Thank you. All right, I think we're done. Thank you.